Now we discussed in part 1, part 2, part 3, part 4 the theory, the concept of locus of complex numbers, about ellipse and hyperbola. So we see some examples, some problems on those concepts. For example, modulus of z minus 2 plus I plus modulus of z plus 3 minus 4I equals to 5. So here this is the some condition given using the complex number where z is the variable complex number. So we have to find out what is the locus of z here. So to find out the locus of z, first you have to identify that this equation is in which form. That is, in part 1, 2, 3, 4 we have discussed two forms. So out of that, what is the form this problem? That is, here we can see plus. So you can imagine that it is in the form of modulus of z minus z1 plus modulus of z minus z2. Now be careful, after z it should be minus. After z it should be minus. So what I will do, say here modulus of z minus 2 plus I can write 2 minus I plus modulus of minus should be there. So what I can write plus 3, we can write minus 3 because of minus into minus will become plus, and I can write this as plus 4I equals to 5. Now you can see this modulus of z minus z1 plus modulus of z minus z2 equals to 5. So this is z1 and this is z2. So now how it look like? Modulus of z minus z1 plus modulus of z minus z2 equals to 5. So whenever modulus of z minus z1 plus modulus of z minus z2 is equals to k, something like k is given. So the locus of z is depend on k. So that k is more than modulus of z1 minus z2, equals to modulus of z1 minus z2, or less than modulus of z1 minus z2. That we have to see. So first I will calculate what is modulus of z1 minus z2. So here z1 equals to 2 minus I, z2 equals to minus 3 plus 4I. So therefore the difference of these two complex numbers z1 minus z2 equals to 2 minus I, subtraction minus of minus plus 3 minus 4I. So this equals to 2 plus 3 5, then minus I minus 4I minus 5I. So I got z1 minus z2. z1 minus z2 equals to 5 minus 5I. Now modulus of z1 minus z2 equals to what? So its magnitude, its length. What is the formula? Root of x square plus y square. So therefore 5 square 25 plus 5 square 25, that equals to root 50. So here modulus of z1 minus z2 equals to root 50. What is this? We supposed here k, that equals to 5. K equals to 5. So now compare k and modulus of z1 minus z2. Because of the locus of z is totally depend on the values of k and modulus of z1 minus z2. So here k equals to 5, this is root 50, that means more than root 25, this is root 25, it is more than root 25. So therefore k value is less than root 50, therefore k value is less than modulus of z1 minus z2. Therefore k is less than modulus of z1 minus z2. So here, if you remember all those properties, if k less than modulus of z1 minus z2, what is locus of z? If k is greater than modulus of z1 minus z2, what is locus of z? And if k equals to modulus of z1 minus z2, what is the locus of z? If you remember that rules, now it is easy to decide what is the locus of z. k less than modulus of z1 minus z2. Now, if you have remembered the property, it is easy to say that there is no z exist because of modulus of z minus z1 plus modulus of z minus z2 equals to k. If you have, what is modulus of z minus z1 plus modulus of z minus z2? I told geometrically that this is sum of the lengths of two sides. Therefore, sum of the lengths of two sides, which is k, should be more than the third side. But here it is not the case. K is less than modulus of z1 minus z2. Therefore, the locus is an empty set because of there is no z exists satisfying the given condition. Modulus of z minus z1 plus modulus of z minus z2 equals to k. Now, instead of that, if I take the same condition I am writing, but little bit change. Modulus of z minus 2 plus I plus modulus of z minus plus 3 minus 4i, that equals to 8 if I take what happens. Now, previously we calculated what is modulus of z1 minus z2. We got root 50. Now you see here the value of k is 8, that is root 64 you can say. So root 64 is more than root 50 obviously. So therefore k is greater than modulus of z1 minus z2. It's a basic observation because of 8 means root of 64 and 64 is greater than 50. Therefore root of 64 is greater than root of 50. That's why k is greater than modulus of z1 minus z2. So therefore, whenever modulus of z minus z1 plus modulus of z minus z2 is equal to k and k is greater than modulus of z1 minus z2, what happens? The locus of z is an ellipse. So, if locus of z is an ellipse, what are the foci? Z1 and Z2, they are the foci. So therefore, foci of the ellipse you can write foci of the ellipse. Foci of the ellipse, you can write what are the foci. Foci are here, Z1 and Z2. Z1 is what? Z1 equals to plus 2 minus I. 2 minus I. That you can represent in 2D geometry. Like real part we write as x coordinate, imaginary part we write as y coordinate. Now it is Z2. Z2 is the another focus, that is minus 3 plus 4i. If you want to express this is in the 2D geometry, the real part will be written as x coordinate minus 3 and imaginary part will take as y coordinate, so 4. Therefore we got the foci and locus of that is ellipse. We have the foci 2 comma minus 1 and minus 3 comma 4. And I told you to find out eccentricity of the ellipse. There is a simple formula connected with this condition. Eccentricity E is equals to modulus of z1 minus z2 divided by k. Now here we have modulus of z1 minus z2, that equals to root 50. If you want to calculate this root 50, you can simplify 25 into 2 and 25 value root of 25 is 5. So you can say this is 5 root 2. So modulus of z1 minus z2 is 5 root 2 divided by k. The value of k is 8. Now one more thing you can observe, that the denominator 8 root 64 and this is root 50. Denominator is more than 1. Denominator is more than the numerator. So therefore this fraction is less than 1. Obviously it should be, because of eccentricity of the ellipse is always less than 1. So that's why it's correct. E is equal to 5 root 2 by 8. Now if you want equation of the ellipse, also you can find out with the help of eccentricity and focus. Now you see the next example. Find the locus of z if it satisfies that condition. What is the condition? Modulus of z minus 2 plus modulus of z plus 1 plus 4i equals to 5. Now here we have to find out once again using the same concept. Modulus of z minus z1 plus modulus of z minus z2 equals to k. So here we have again plus, like in the previous two examples. I took one more example using plus because of third case is there. Now here what is z1? Z1 equals to 2. So be careful while you are selecting Z1 and Z2. It should be after minus. So here it's clearly minus we have in between. So therefore Z1 is equals to 2. But here we have plus. So we have to write minus of. So whenever you write minus of, Z2 will be minus 1 minus 4i. Now I'll calculate Z1 minus Z2 because of I want to know what is the relation between K and modulus of Z1 minus Z2. What is K given to you here? K equals to 5. So we have to compare this number K with the modulus of Z1 minus Z2, which gives the result, that is the locus of Z. So Z1 minus Z2, that equals to 2 minus of this, so plus 1 plus 4i. So 2 plus 1 equals to 3 plus 4i. Now I got Z1 minus Z2. Now I'll calculate what is modulus of Z1 minus Z2. That is the square root of real part square. Real part is 3. So 3 square 9 plus imaginary part is 4. Coefficient of I is imaginary part. So coefficient of I is 4. So 4 is imaginary part. Imaginary part square. So 4 square, that is 16. 4 square, that is 16. So root of 9 plus 16 is what? 5. Now you see what happened. Here K value is 5 as well as modulus of Z1 minus Z2 is also 5. So therefore they are equal. K equals to modulus of Z1 minus Z2. So in this case, according to the concept, if K equals to modulus of Z1 minus Z2, Z1, Z2, they are collinear. And also the locus of Z is a straight line. The locus of Z is in fact line segment joining Z1 and Z2. So therefore the locus of Z is a line segment joining Z1 comma Z2 is a line segment. Okay, now what is Z1? If you want to write as a 2D geometry, in 2D geometry, Z1 is equals to 2 is a real part. Where is imaginary part? No imaginary part. So therefore we will take 2 comma 0. Z2 equals to, what is the real part? Minus 1. What is the imaginary part? Minus 4. So minus 1 comma minus 4. That is Z2. So if you want to find what is that line, you can, because of it 2D geometry, we know how to find the equation of the straight line joining the 2 points. 2-point form you can use and you can obtain what is the equation. Okay. Now next is, if we have minus, how to know the locus of Z. So we are going to discuss in the next examples. Now you see this example. Modulus of Z minus 2 plus I minus modulus of Z minus I equals to 1. So again, what is Z1, what is Z2? First we have to write, and we know the value of K is here, K equals to 1. But here given difference. So whenever difference given, the possible locus is empty, maybe empty set, or maybe hyperbola, or array. So what is that? We have to decide now. Z1 is equals to, so after minus we have to write, that is 2 minus I, or you can say reversing the symbols, plus 2 minus I. And here we have minus sign, so plus I. Therefore Z2 is equals to I. Then we can calculate what is Z1 minus Z2. Z1 minus Z2, 2 minus I minus I, that is 2 minus 2I. So immediately I calculate what is modulus of Z1 minus Z2. That is equal to, if you calculate root of 4 plus 4, so root of 4 plus 4 is root 8. Now you see the value of K. Value of K is 1, and this is more than 1. Obviously root 8 is something 2 point something, nearer to 3. So here K value is 1, which is less than root 8. So therefore K is less than root 8 means modulus of Z1 minus Z2. So K is less than modulus of Z1 minus Z2. So according to concepts we discussed in the previous lessons, the locus of Z is a hyperbola. Therefore the locus of Z is a hyperbola. Now once again, the same thing like we explained in the previous examples, this Z1 comma Z2 are foci, and if you want you can find out eccentricity also using the same formula. E is equals to modulus of Z1 minus Z2 divided by K, that equals to modulus of z1 minus z2 we calculated here root 8 and divided by k value is 1. So that is equals to 2 root 2, and obviously this is more than 1. So therefore eccentricity of the hyperbola is equals to 2 root 2. Now you see, instead of 1, so I took here 1. So instead of 1, if I take exactly this value, root 8, so in that case what happens? K is equals to modulus of z1 minus z2. So if k is equals to modulus of z1 minus z2, according to our discussion in the previous lessons, what happens? The locus of z is a ray. So what is the direction? If you want to know exactly the direction, if you want to know exactly the direction, so see the exact picture of the locus. Now here z1 is equals to 2 minus I. 2 minus I means what? That point, the real part is 2, imaginary part is minus 1. So 2 comma minus 1. So x value is 2 and y value is minus 1. So it is located here, 2 comma minus 1. This is z1. Now you see z2 is equal to I. So z2 is equal to I, we can write real part is 0, imaginary part is 1, 0 comma 1. X coordinate is 0. So therefore that point is on y axis at distance of 1 unit from the origin. So this is, here we have z2. So if I join these z1 z2 by a straight line, you see the line joining z1 and z2. So where is our locus? How to know that line or how to know that ray? Because of whenever k is equals to modulus of z1 minus z2, what we are saying? The locus of z is a ray. Now you see the first value, modulus of z minus 2 plus I, should be more than modulus of z minus I. So therefore z should be away from this point z1. That means the distance from z to z1 should be more than the distance from z to z2. Once again I repeat that distance from z to z1 should be more than the distance from z to z2. So here we have z1, here we have z2. So where that z is moving, because of z and z1 distance should be more. So if I take z here, z and z1 will be obviously more comparing with the z2. So therefore the locus of z is a ray in the direction of z1 z2, that is outside of the line segment z1 z2. Therefore the locus of z is in the direction, is a ray in the direction of z1 z2. So that is the locus of z denotes this portion. This is the ray starting from z2 moving in the direction of z1 z2. That is the locus of z whenever k equals to modulus of z1 minus z2. Now you solve some more problems on the same concept